Today in lesson 2-2, what we're going to talk about is describing the center of distribution. So in previous work with data distributions, we learned how to derive the mean and the median of a data distribution. So what this lesson is going to do is it's going to build on your previous work with a center. So they want us to consider the following three sets of data. So the data set 1 talks about pet owners. It says, students from River City High School were randomly selected and asked, how many pets do you currently own? The results are recorded below. So there's all of those results are right there. So we want to look at this. First off, we're going to talk about, can you assume that all the students will interpret the question, how many pets do you currently own, in the same way? Well, really, if we think about it, there's no other way to talk about how many pets you have, so everyone would have to interpret it the same way. So we could say, yes. Now let's look at data set 2. It says the length of East Hallway at River City High School. So 20 students were randomly selected to measure the length of the East Hallway. 2 marks were made on the hallway's floor. One at the front of the hallway and the other at the end of the hallway. Each student were given a meter stick and asked to use the meter stick to determine the length between the marks to the nearest tenth of a meter. The results are recorded below. So if we look at this, if everyone was given a meter stick, why would the same hallway have different reported measures of length? Well, one of the reasons could be either human error, or the measurement. So when we're measuring, it could be off. So we could have a measurement could be a little bit off. Okay. And they want to know, what measures of length in the hallway do you think is the most accurate for the data set? Well, it would be the one that would be in the middle of the data set. So the measurement that would be in the middle. Or in the middle number is also known as the median. Okay. So now let's look at the last data set 3. They say age of cars. So 25 car owners were asked the age of their cars in years. The results are recorded below. So they want to know, what number would you use to describe the typical age of cars in each year by the car owners in this group. So basically the numbers that I would choose is the one that happens most frequently. Okay. So the typical age of the car in years would be 8, because it occurs most. But now what we're going to talk about is we're going to go into finding the mean and the median and seeing what's the difference between the two. So let's go into this. So they want us to make a dot plot for each of the 3 data sets. Okay? And a dot plot provides a graphical representation of a data distribution, helping us to visualize the distribution. So if we look at this, we're going to first look at how many zeros there are. So if we look at our data here, if we go back to the other page, we can see we're just going to count up how many zeros there are. There's 1, 2, 3, 4 zeros. So on my dot plot, I'm going to put 4 zeros. 1, 2, 3, 4. So there's 4 dots there. Now we go back to our chart and we look at how many are ones. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 ones. So we're going to go over to 1 on the number line, which is between 0 and 2. So it'll be right here. And we're going to put 10 dots. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then if we look at how many there are of 2, so there's 1, 2, 3, 4 2s. So on this one, I'm going to put 4 2s. 1, 2, 3, 4. Okay. And now let's count how many we have that are 4, just 1. So when we go back to this, at 4, we're going to just put 1. Now if we look at 3s, we have 1, 2, 3s. So we have to go in between 2 and 4 and just put 2. Now let's look at 5s. We have 1, 2, 5s. So at 5, we're going to go up 1, 2. Okay. How many 6s do we have? We have 1, 2 6s. So we're going to go at 6, 1, 2 6s. How many 7s do we have? Well, we just have 1 7. And then we should have how many 8s? Just 1 8. And 1 9, 1 10, and 1 12. So let's go through and put that in. 1 8, 1 9, 1 10, and 1 12. Now we should be able to count up all of our dots, and we want to make sure that we have the same amount that we started with. So if we started with this many, if we count them all up, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So we should have 30 dots altogether on our dot plot. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, and 30. So now we're all set with that. Now let's look at the length of the east hallway. So if we were looking at the length of the east hallway up here, okay, we would have, so I'll just zoom out a little bit so you can see. So we'll start with 8.2. So there's a 1, 8.2. So at 8.2, I'm going to put 1 dot. Let's see, 8.3, there's 1, 2. So I'm going to put 2 dots at 8.3. 8.4, if we look up here, there's 1, 2. So at 8.4, I'm going to put 1, 2. 8.5, there's 1, 2, 3, 4, 5. So I'm going to put 5 in there. 1, 2, 3, 4, 5. 8.6, there's 1, 2, 3. 8.7, there's 1, 2. 8.8, there's 1, 2. And 8.9, there's 2 of them too. Alright, so now let's move on to the last one. For our last dot plot, we have the age of cars. So on my age of cars, so I have 0, there's 1 0, there's 1 1, there's 1 2 2s, there's 1 3, there's 1 4, there's 1 2 5s, there's 1 2 3 6s. How many 7s are there? 1 2 3 4 5 6. How many 8s are there? 1 2 3 4 5 6 7 8. There's 8 8s. 1 2 3 4 5 6 7 8. Okay? And we want to make sure that we have the same amount of data from our chart that we have on our dot plot. So together we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So we know that they should have 25 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Okay? So now we have all three of our dot plots drawn for all three of our data sets. Now what we're going to look at is we're going to talk about whether they are skewed or whether they are symmetrical. If they are skewed, that means that most of the data is either to the left or it's to the right. So looking at this, our first example here, if we look at the number of pets, most of our data is to the left. So this one is going to be skewed left, and we can say that the tail end is to the right. Okay, and if we look at the east hallway length, if we look at this, it kind of follows a mound curve. If it follows a mound curve, we could say that it's nearly symmetrical. And then for the last one, you could see that most of the data is to the right. So that's going to be skewed again, and it's going to be skewed to the right. So we'll say skewed to the right. And that means that the tail is to the left. Okay. So now what we're going to do, we're going to move into actually finding what the mean and the median are. So it says, the mean and the median of the distributions are the numerical summaries of the center of data distribution. And again, the median is just the middle number. And the mean is just the average. So they want us to calculate the mean number of pets owned by the 30 students at River City High School. So if we go back to our chart for our pet owners, so we'll put it, so we have our chart. If we wanted to find the mean, let's find the mean first. If we wanted to find the mean, what we'd have to do is just add up all the numbers and divide by the number that we have. So I'm going to add up all these numbers in this chart. So I'm going to have 1, 2, 3, 4 zeros. So I'm going to do 0, plus 0, plus 0, plus 0, plus, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 ones. So it'll just be 1, and then we have to add 1, 2, 3, 4 twos. So it'll be 1, 2, 3, 4. And then we add 1, 2, 3's. So it'll be 2 3's. And then we have 1, 4 plus 1, 2, 5's. We have 1, 2, 6's. Plus 1, 7, plus 1, 8, plus 1, 9, plus 1, 10, plus 1, 12. So we added them all together, and then we have to divide by the number that we have. So we figured out that there's 30 of these, so it would be divided by 30. If we were to add them all up, add all the numbers up, and divide by 30, we would get 96 divided by 30, which is equal to about 3.2. So we know the mean is going to be 3.2. Now to find the median, I like to list all the numbers from least to greatest. But in our chart, they already gave it to us least to greatest. So all I have to do is just list them out. 0, 0, 0, 0. 1, 1, 1, 1, 1, 1, 1, 1, 1, 2, 2, 2, 2, 3, 3, 4, 5, 5, 6, 6, 7, 8, 9, 10, 12. And if I wanted to find the median, what I'd have to do is I would just have to go through and actually find the median. So start on the outside and work your way in. So I start on the outside here and work my way in to find that middle number. And if we look, the two middle numbers are going to be 2 and 2. So that means that our median has to be 2. Okay. So now if I go on to the next one, they want to know, what do you think that is the typical number of pets for students from River City High School? And explain your answer. So if we look at this, since it's skewed, that would mean that we would want to use the median would be a better option. So I'm going to say skewed left would mean that the median would be a better option. Because if you think about it, if it's skewed left, that means that there's going to be higher numbers that will bring the mean down. So we could say that the value of the mean is pulled up by the larger numbers of the data set, or values in the data set. Okay? And then exercise 4 says, why do you think that different students got different results when measuring the same distance in the hallway? Well, the first thing could be measurement errors. The placement of the meter stick. Okay. Also, when we're measuring and we pick up the meter stick, that could also be an option that we have here. Okay. So that could be the alignment of the meter stick. After each length was made. And the last thing could be, when you're trying to measure it, could be that you're reading the meter stick wrong, or just human error. So we could say the interpretation of a person with the meter stick. Okay, and now what they want us to do is they want us to calculate what is the mean length of the hallway, and they want to know what is the median length. So I'm going to first start off with my mean length. So if I was doing my mean length, I'd have to add them all together. So I would take my chart here, so I'll just look at it. So if I'm trying to find my mean length of my list, so this is my chart. To find my mean, all I'm going to have to do is just add all these numbers together and then divide by the total number that we have. So I'll have 8.2 plus 8.3 plus 8.3 plus 8.4 plus 8.4 plus 8.5 plus 8.5 plus 8.5 plus 8.5 plus 8.5 plus 8.6 plus 8.6 plus 8.6 plus 8.6 plus 8.7 plus 8.7 plus 8.8 plus 8.9 plus 8.9. So I added them all together, and then what I'm going to have to do is just divide by the number that we have. And again, for this one, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we're going to take that, or whatever our answer is, and then we're going to divide by 20. So if you added those two together, if you added all those numbers together in your calculator or on your own, you should get 171.3, and then we're going to divide that by 20 to get about 8.565. So there's our mean. Now what we want to do is we want to find the median. So I'm going to list all those numbers out. So if we find the median now, I'm going to list all my numbers from least to greatest, and then find the one that's in the middle. So if I list all these out, I would have 8.2, 8.3, 8.3, 8.4, 8.4, 8.5, 8.5, 8.5, 8.5, 8.5, 8.6, 8.6, 8.6, 8.6, 8.7, 8.7, 8.8, 8.8, 8.9, and then 8.9. So now what I'm going to do is I'm just going to go through and start at the beginning, start at the end. Start at the beginning, start at the end. And just cross out all these numbers. So beginning, end. Beginning, end. Until I'm going to get to the middle number. So beginning to the end. Beginning to the end. Beginning to the end. Beginning to the end. But now I have these two are in the middle, 8.5 and 8.6. So what I'm going to have to do is I'm going to have to find the average of those two to find the mean. So I'm going to take 8.5 plus 8.6 and then divide it by 2. So I'll get that would be approximately 8.55. And if you notice, you can see that the median and the mean are going to be, they're approximately the same. 8.55, 8.565. So they'll be approximately the same. So if we're looking at that, we know that they're approximately the same because our data for this set was approximately symmetrical or nearly symmetrical. So now they're asking us, a construction company will be installing a handrail along a wall from the beginning point to the end point of the east hallway. The company asks you how long the handrail should be. What would you tell the company and explain your answer? Okay, and since the distribution is nearly symmetrical, the mean would be a better use for the center, or an average. So that's what we're going to write down. So we could say, since the distribution is nearly symmetric, the mean should be used as a measure of center. So if we're using them, since they're, and that's because too, they're approximately the same. So the mean could be used, so we're going to just round it off and say that the handrail should be approximately 8.6 meters. Okay, and that's again because the distribution is symmetrical. We would just use the mean. Okay, let's go on to this last page. So it says, when the distribution is nearly symmetrical, the mean and the median of the distributions are approximately equal. They should be very close to each other. When the distribution is not symmetrical, as we call it, skewed, the mean and the median are not the same. So, for symmetrical distributions, the mean is the appropriate choice for describing a typical value. So if it's symmetrical, we should use the mean. If it's skewed, we should use the median as the better description of a typical value. So they want us to describe the distribution of the ages of cars. And we know that the ages of cars, from looking at our data earlier, we know that for our cars, age of our cars, it's skewed to the right and tail to the left. So, how can we describe it? The exact same way. We could say that it's skewed right with the tail to the left. So, we also know that with the distribution of the cars, that it is not symmetrical. Okay? Alright, so now for exercise 8. They want to know what is the mean age of the 25 cars. And they want to know what is the median age. And they want to know why are the mean and the median different. Well, we know when it's skewed at all, that it's going to be different. That mean and the median are not going to be the same. So, they want to know the mean. So let's find the mean first. We're going to add up all the values. Okay, and then divide by 25. So if we're adding up all of these values, if we go back to our age of the cars, we're going to go through and add all these values together. So we're going to add all these values together and then divide by the number that we have. So we have 1, 0, so it'll be 0 plus 1, 1, plus we have 2 2s, plus 1, 3, plus 1, 4, plus 2 5s, plus 1, 2, 3 6s, plus 1, 2, 3, 4, 5, 6, 7s. So it'll be 2, 3, 4, 5, 6. And then we're going to add our 8s. 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 8s. 1, 2, 3, 4, 5, 6, 7, 8. So we're adding all those up, and we're going to divide by the numbers that we have. So if we do that, we're going to divide by the 25 cars. So if we added these all up, all these numbers, we should get 146. And then we're going to divide by 25, and we'll get the mean to be about 5.84. Now if we go through and do the median, if we're doing the median, we're going to list all the numbers from least to greatest, and then find the middle one. So I'll have 0, 1, 2, 2, 3, 4, 5, 5, 6, 6, 6, 7, 7, 7, 7, 7. So we should have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. And then we should have 8 8s. 1, 2, 3, 4, 5, 6. So we'll have 8 8s. 1, 2, 3, 4, 5, 6, 7, 8. So now what I'm going to do is I'm just going to start at the beginning and start at the end and just cross out. So I have one at the beginning, one at the end. 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 One at the end, one at the beginning, one at the end. And we see that our middle number here is going to be 7. So that means that our median is 7. And we see that 5.84 and 7 are two different numbers. They're not even approximately the same. So they want to know what number would be used to estimate as an estimate of the typical age of the cars of the 25 car owners, and they want to explain our answer. Well, since we know that it's skewed, we know that the median is a better